Alright, hello everybody. Welcome to a slightly slightly impromptu video that I'm going to be working on here. So I met with some of the folks from Herrnhuter, and they actually expressed an interest in finding a USB-powered lighting solution for their stars. It was a really exciting conversation, two very lovely people here in Vancouver. And they gave me some material to work with to work on some prototyping. Now, I was just sitting here working mentally through some of the the ideas and concepts that I had rattling around in my head, and I decided I'd show part of what I was doing here. So the original way these stars are lit is with these little E10 bulbs. Now, the E10 bulbs are actually, this particular one is rated for 6.3 volts at 0.3 amps. So if we plug that in, let's see, what do I have this set to? I have this set to 4.69. What does it say, 6.3? Okay, so 6.3 volts on an E10 bulb, and that's what that looks like. It's not incredibly bright. It's not too I can look at it without being too painful there. And a USB power supply, if I crank this back down to 5 volts, we still get a fairly decent amount of light off of that E10 bulb. So the E10 bulb that these are normally powered off of is potentially a viable solution, but tungsten bulbs like this one will go bad. They burn out or shatter, or any number of bad things can happen to one of these little tungsten bulbs. So the company has actually already looked into the potential of working with an LED bulb, and this is what they've released. Is this little thing, and this one is rated at also 6.3 volts. I'm going to turn my power supply back up here to 6.3 volts. There we go. And this is what that solution looks like plugged in. Give it power. So it's a little bit brighter and sharper than the E10 bulb over there. They've got it set for a nice warm white there. That's a very yellowy warm white, actually. But here's the issue when it comes to LEDs. Whereas with the tungsten bulb, I can just crank the voltage down a little bit, and it's gonna glow fairly close to the 6-volt one. Watch what happens when I crank this little LED 10 bulb down to 5 volts. Yeah, pretty disappointing output there. So that's a fairly reasonable thing to have happen there. Each of these LEDs is going to be having a forward voltage drop of about 3.2 to 3.4 volts. So I assume, based on the arrangement, that they've got 2 of these LEDs in series, and then all 5 of these sections in parallel with each other. So for this video, we're actually going to take this apart. They've given me permission to take apart the one that they gave me, and see what's on the inside. So we're just going to set that thing aside. We don't need this anymore. Actually, we don't need any of these just yet. So I am going to need probably the vise here, and I'm going to need some desoldering braid. Probably going to need my flex pen too. Where did that go? That's on the floor. Why is that on the floor? Oof. Yeah. There we go. Flex pen. Alright, so going to start by just very gently, because I want to preserve the threads, very gently clamping down on that. And then I'm going to grab the soldering iron here. And what I'm actually going to do, you're probably looking at this saying, why is he putting solder on? Now these are going to be made with lead-free solder, which always makes it a little bit difficult to desolder it. So I'm just gonna flow lead-bearing solder onto it, and then applying my solder wick, just draw all the solder off of the pad. Now let's see how that worked. May have done the trick. We're just going to repeat that process on each of these pads along the top. And remove, hopefully, the top of the LED here. So there's that. This requires a fair amount of concentration, so I'm not saying much. So I'm beginning to see an issue here. We may have to address that in a moment. Doesn't look like all of the solder is coming out of the pads, which is going to make this slightly more difficult. I'd like to not have to totally destroy this thing in order to take it apart. It'd be kind of nice if I could stick it all back together. And I'd even be able to return it to the no lead-bearing solder standards, because I have some silver solder sitting right over there. So I'm gonna dab my soldering braid here with a little bit of flux, just to kind of supercharge its solder sucking ability. Big whoosh of smoke there. Oh yeah, that did beautifully. Let's see. I'm pretty sure that one pulled all of it off. Alright, well, I've shown you enough of the technique of taking this apart. I'm going to go ahead and work on this off camera for a bit, and I'll come back when I'm ready to start actually tearing it apart. So we'll be back in a minute. Alright, we're back. That top part was actually a lot easier to remove than I thought it was going to be. It looked like it was still sealing itself together with flux, but with solder, but it actually wasn't. The construction of this thing is actually pretty neat, and I'll just continue on and demonstrate here how they've put it together. We'll just do this and suck that solder right off that pad. Once the solder's gone, the board just comes out. It's got a little tooth that slips into the bottom of the board there, and then oops, I need to flex this. And then the solder gives, you know, the sealing onto the board so that it stays put. It's a fairly simple design, but it gets the job done. Ow. Whew, that's getting toasty. That's the problem with the soldering braid, is that it does conduct heat, and if you use it for an extended period of time, that heat does start to travel up the braid. So we're just gonna undo this last little section here, suck off the last of that solder. There we go. And there's the base of the E10 bulb. Looks like we've got a post coming up from the inside here that may also need some desoldering, so we'll dab that with some flux. Clamp down on this a little bit tighter so that that doesn't wander off. Are you soldered? Yes, you are. So we'll just oh, there we go. There we go. We'll try to remove the solder from this joint. This is going to be troublesome. I don't want to bore you with this, so I'll be right back. Alright, and we're back. That last phase of taking the thing apart was a little bit more complicated than I had planned on. I had to find my desoldering pump and all sorts of things, and unfortunately I think I probably ruined the bulb because I didn't realize as I was removing this base part from the threads that the PC board here had been soldered all around the edge of the lamp base here. So in removing that, I kind of mangled up the tracks. I probably won't be able to put this back together. Aside from that, though, this is a fairly intelligently designed bulb, which I should hope that it would have been, because they probably spent a lot of money getting these designed for them. Each of these little boards has a current limiting resistor on it, which is kind of nice. So I'll draw you a diagram in a second. And then this one actually has a capacitor, probably for some sort of current inrush limiting capacity. I'm not too sure why it's just on the one, because these are all wired in parallel. But anyway, so what we basically have here is we've got our +5, well, +6.3, I guess, and then minus. So we're just going along the rail, and then we've got this. We've got our current limiting resistor of 30 ohms. Then we've got our 2 LEDs. Like so. And then continuing on, same situation. Pardon my really messy LEDs here. And so on and so forth 5 times. And one of them, for whatever reason, has a capacitor of I was not able to measure it, but there's a capacitor in one of these parallel pairs. Now, the one thing that it didn't have that I found a little disappointing was a bridge rectifier. Now, some of you may be thinking, well, it's a DC circuit, it doesn't need a bridge rectifier. But in the application that they're using these, it would be an intelligent part of the design because the input is not polarized. So you're going to want to do what's called reverse polarity protection, which uses a bridge rectifier. So what you would do for this circuit is, I'm going to get another note card here, bear with me, there we go. So you're going to have your bridge rectifier here. Let me see if I remember how to sketch these properly. And then that one needs to also be like this. Then we're gonna go in this direction, and then that one actually needs to be going in this direction, like so. And then is this correct? Yes. And like that. So you're gonna have the plus, plus voltage coming off of that side, minus voltage coming off of this side, and then you're gonna go into the circuit just like we had before. Like that, and like that. And then a resistor. And then the resistor, LED, LED, LEDs are actually kind of a pain to draw. So, and then so on and so forth. And then you're going to have your source voltage coming into here. And because of the bridge rectifier, it doesn't matter which way the DC gets plugged in this arrangement, because no matter what, the diodes are going to route the positive voltage to the positive terminal and keep the negative negative. So from there, that LED or that lamp could be plugged in, and these power leads could be plugged in any direction, and the lamp would still light. So that would be my only suggestion for improving these bulbs. And now I am going to have to go figure out how to make a 5-volt solution for these stars. So thanks for watching. I'll put a link to subscribe right there. An interesting video here, and we'll see you all in the next video. Bye bye.